I am terrible at overnight support. I was first on overnight support over a decade ago now. I was working for an investment bank. The first time I got called, I can't actually tell you very much because apparently I answered the phone, but I can't remember anything. What happened is I went into work the following day and I got a real bollocking from my boss. So I had taken the call in my sleep. I thought I was taking a call from James Bond and I was going on a new mission. Ops didn't quite understand whether I was taking the call or not, so they just went tick. It's been action, this problem's been solved. It's only to the next day when I spoke to them that we worked out what happened and related it to the dreams that I could remember. So needless to say, I have a vested interest in not being called in the middle of the night. I come from the FT. It's very strange to be at the Telegraph, I've got to say. Very different buildings. I come from the FT and they had to break news and that was critical to their brand. And I was lucky enough to be part of a greenfield project that built all of their content APIs from the ground up again. This sort of resiliency and high availability were very much crucial to the success of this. We had to also tackle the operational concerns around building this platform. Since then I've moved on to River Island, where I further sort of refined those thoughts. And I don't want to be put on overnight support until I know that I'm not going to be called. So nowadays we're building really, really complicated systems. The diagram over here, it is the content platform at the FT. The reason I know that it's so complicated is that this is completely incomplete because my lucid chart skills completely failed me on several projects. I don't know quite why we tried to diagram it this way. But we're building these distributed systems that are massive. We cannot keep all of this in our heads. So we need to work out how we're going to operate them. Martin Fowler said there's some downsides to microservices, and the operational cost of running these huge platforms is one of them. They're complex by nature. We're deploying so much more regularly. We're throwing new services constantly out there. So one of the teams I work with at River Island, this is just some of the technology that they're using just on one team. And we're empowering dev teams to choose those technologies that are suited for their business need. But this means that they're using a plethora of technologies. So the old model of having sort of first line operations, dealing with all of these sort of mini platforms in themselves, it doesn't scale. And imagine having a whole organisation of these teams. Everybody's doing something slightly different. How do you support this? But empowering teams doesn't mean just empowering them to choose the right tech. It also means that you should be empowering them to define the support process they want to support this tech with. Define how they work with, say, a first line support model, if you have it. They need to consider so much more than just the business value that they're being asked to give. When I first started work at the FT, our content API was so flaky that all the internal consumers put caching in front of it. It was up and down all the time. We then got told we had a 15-minute SLA. So if there's a problem, we had to recover within 15 minutes. Then we got told we had to migrate our platform to Kubernetes because, we had made a wrong decision along the way. Completely different talk on that if you want to hear it at some point. But what we ended up with in the end was something I realised that I was really, really geeky at a party and went round my old colleagues after leaving and asked them about their recent support calls. And it turned out that for the last 6 months, they haven't had a support call that actually needed any development interaction overnight. They've had a call from a new first-line support staff, nervous about doing something and just needed some reassurance. Now, what I'm saying, what we built is not this mythical unicorn of a application that never fails, it's always up, it's always resilient. No, not at all. What we built was something that meant that we could action things in our own time. And we could do it the way that we wanted to, rather than having to get up and get onto our laptop at 3 a.m. So I realised there was about 5-ish things that we approached this whole problem with. And I'm going to talk to you about those 5 things today. When I first wrote these slides, and this sort of section was right in the middle, and as I developed the slides, it became quickly apparent that this is the number one thing that you need to do. If you do nothing else that I talk to you about, just think about this one. Because at the end of the day, if the developers don't own the sort of callback mechanism, nobody's going to develop it. So it needs to come from the ground up. Now, Charity Majors, I'm pretty sure everybody, hopefully, if anybody isn't following her on Twitter, do, because she's an absolute genius. I really agree with what she says here. I don't come from a sysadmin point of view. I come from an old school application design development sort of way. But it should be a primary concern. Operability should be a primary concern. How do we operate our systems now? When do we want to retry? How do we want to be called out? When do we want to be called out? Or do we just want to simply know about an event? And the most important part is enabling the teams to define this support model. Trust them to know best how to react and when to react. It's also letting them build the relationships within the organisation. So if you do have that first line operations team, how do the development team work with them? What's that relationship like, and what is needed there to be effective? We had a bash at this at the FT, and what we did is that we had a model that was completely voluntary for call out. We basically had 2 buckets of developers, and what this enabled is that the operations team would round robin call everybody in that bucket. It meant that if you had a spur of the moment desperate need to go to the pub or a cycle ride, or you were at a wedding, they would just go on to the next person. The only time that doesn't work is when the entire support team is down the pub. We have found that one once, very early on. But it also meant that we needed to build that relationship again with the operations. And we also needed to provide operations with the tooling to make so that they can make the decision whether to call us or whether they could handle things themselves. And that was an important part of that relationship. The other part of this was that we didn't stop the support model during the day. So we would have dedicated people during the day that were taken off project work, normally for a week, and they would triage support issues during the day. This had a couple of things. It meant that gave us a couple of things. It meant that they were playing with the platform all the time. They weren't nervous if they were going on an on-call rota. You saw the diagram earlier. There's a lot of complexity there. So they could get confidence in dealing with other parts of the system. And it also meant that most people didn't really like being pulled off the work and being put onto that triaging thing. So they actually incorporated every single thought pattern around being on support into their day-to-day business value. So when they were writing a bit of error handling, very simple one there, they were asking, do I need to be called? Do I need to alert? What do we need to do under this error circumstance? And then we took that one step further. So we then took things and linked it to severity. So we wanted to understand the severity of an error within our applications. Do we want to be called? Do we need to action this during business hours? Do we actually not care about it for the moment? This one behind us, so this was an example of aggregate health check page that we had, and we were running CoreOS in our Kubernetes cluster, but we wanted to know when we had to upgrade. But we didn't want to be called at 3 a.m. being told to upgrade, but we wanted to make sure that nobody did anything the following day without it. So here it's just saying that we needed to upgrade that. There's a couple of laws by Lehman and Belody. They did this is 1996 one. They've done some much earlier stuff, but it's saying that there's declining quality unless things are rigorously maintained. And I take the idea that that's not just for software, it's for process as well. So operational process. If you're not refining as you're building your system out, that will decay and those relationships will decay. Even earlier law from them, of course, as you build bigger things, the more complex it gets. So your operational model needs to adjust to that. You can't put something in place in day one and expect it to still be valid 6-12 months down the line. So that's talking about the engineer's mindset. We're empowered to change this stuff, or I'm hoping we're empowered to change this stuff. We should be owning the support model. We shouldn't be conforming to that. We should be driving change in that area. If we don't have the power to control when we're being called, then we need to start having those conversations. Now my second bit, we don't want to be called when we don't need to be called in the middle of the night. The biggest thing to avoid that, or the biggest thing that might cause that, is releases. So with the best will in the world, we can't stop a release, we can't completely eliminate a release not waking us up. You know, there might be something that you don't see immediately, a degrading service that happens due to a slow leak of data or something along these lines. Releases are always going to be the biggest reason for possible call-outs. I was wondering whether, who gets nervous about releasing at 5 p.m? Okay, who gets nervous about releasing 5 p.m. on a Friday? Okay, yeah. I'm still slightly on the Friday one, but I think that when your teams are getting really nervous about releasing at 5 p.m, you've got to ask why. They've got to start questioning what could possibly be the impact of this change. How quickly can I know that it's broken? Why are they worrying? And a lot of those things can be eliminated. So also, if you get quick feedback loops on your deployments, then you can start sort of verifying things. This was a problem I had when I first moved to River Island. The man that fixed it was just over here, actually. We were deploying to an ECS cluster, so we were deploying our containers out. Our deployment pipeline said, yeah, everything's great. We've deployed everything out. And then we had to wait 12 to 15 minutes for the service to come up. And we got it down to 5 minutes, but that's still a long time. Now, I go into rooms and forget why I've walked into rooms. And this is very much so here. I will walk off and go and get a cup of tea and forget to check my release when I come back. We need to, if we can't do that. We need to try to make sure that we can feed back an alert so that people verify releases. And on the point of verify, everything you can do to verify in production. We were just talking about testing in production. Nowadays we have a whole huge way of sort of verifying our releases, whether it be production accounts, whether it be canary testing, A/B testing, whatever it is. There's loads of ways that we can now verify our release in production and gain confidence that it shouldn't cause that call at 3 a.m. There's something I saw a talk by James Governor. It's called progressive delivery. He's coined a phrase for this whole post-release testing to verify releases. There's also an amazing woman. I've put a load of links at the end of this if you want to check them out. And she talks about testing in production. But she talks about testing before production. And as was said earlier, is you don't want to just chuck anything out there. Another way that you're guaranteed to get a call at some point or another is 3 a.m. batch jobs. I don't know why everybody thinks about 3 a.m. But if you're doing all your heavy lifting in the middle of the night, something's going to go wrong at some point. And if this is a critical system, then you are going to get called. So this is a little example of an order system. And what it's doing is that we're getting orders throughout the day, we're putting those into a database, you know, sort of event driven in that respect. And then at 3 a.m. we're transforming all of the orders for the day, sending a reconciliation file out to a third party. Now, if anything goes wrong in that transformation, we get a call. And that is where the predominant amount of work is being done. So I say move it towards the real time. Admittedly, this I've oversimplified this diagram, and anybody can point out is that the reconciliation file, there'll probably be conflicts, but the idea still stands, is that if you try to do your transformation real time as the events come in, it means that any data that's bad that comes in during the day, you can action it straight away, and the overnight batch becomes as small as possible. So there, don't get called for stuff during the day. Good principles. A computer is often better at doing things than us at 3 a.m. And so if you can automate stuff, do it. We're now dealing in worlds of Kubernetes clusters and serverless. A lot of the heavy lifting has been done there. Platforms like Kubernetes will sort of monitor all of your services and work out when they need to be restarted or shoved over somewhere else. Whilst these platforms have come a long way, there's still considerations as developers that there needs to have. Applications need to now be able to cope with change. Graceful termination. So, yeah. If the likes of Kubernetes wants to stop something and reschedule it somewhere else, it needs to terminate well. Transactional in the same vein, you don't want your data half cooked. Restarts needs to be restarted on a new machine. Queuebacks, so if there are any failures, you can just rerun stuff. Idempotent. So the mantra of microservices. If things can be redone over and over again and have the same effects, then you're in a good state. And stateless. This isn't ideal. Of course, it's not always achievable. The idempotency comes in really, it's a really big tool, especially if you have failed things going through your system, you can automatically replay. So in terms of the FT, failed publishers, if they were failed, we could replay them. We also had automatic failovers, so we duplicated our whole platform into a different region. And when we saw that there were some real problems over in one, the system just went, okay, yeah, let's serve out of the US. It also provides a backup platform if something goes really, really wrong. However, it comes with a bit of a warning. If you do have a active cluster like we did, it means that code releases to both simultaneously that are broken will of course take down both. And also where infection can spread. We learned this the hard way. So as I was saying, we had a active cluster, a complete replication of that whole diagram, all 150 microservices, Kafka, a couple of data stores, and we had it in the EU and the US. One day at about 6 o'clock in the evening, luckily 6 o'clock in the evening, not 3 a.m., our EU cluster started going completely critical. It went bang, and this is pre-Kubernetes, so we didn't have a lot of tooling. We had written our own orchestration and scheduling platform, which was sensible. Yeah, another talk, as I said. But it was going critical. And this, you may not believe me, but this is actually somebody taking a picture of one of our teammates when he got the alert on his phone. All the rest of the FT people in the pub came round his laptop. I was personally just getting home. I hadn't gone to the pub with him that day. We were losing our US cluster after we started. We failed over automatically to our US cluster. We were absolutely screwed. So we went back to our staging cluster. That started going critical. So what we did is shut down all of our services other than Varnish. We used Varnish to route to our old V1 applications in the data center that still happened to be there because we hadn't got around to decommissioning them. Luckily, very luckily, but we managed to be able to give the FT back the ability to break news, and that was their primary goal. What was happening is that we had tried to containerize a graph database. And what happens with a graph database is that if you don't tell it how it can grow in a container, it will just keep eating memory and eating memory. And it was knocking out VM after VM until we couldn't get quorum and it would fail over. This was one example of where a secondary stack wouldn't have helped. But we didn't really think of this initially. To sort of, there's ways of now sort of, well, of course, stopping your containers growing like that, but also reducing the blast radius of these kind of things. The tooling out there is much better. So automate recovery wherever possible, but do be aware there are some side effects occasionally. The fourth thing is to understand what is actually critical to the business. As I was saying, the FT, the critical thing for them is brand, but breaking news is that brand. So for them being able to, if somebody gets assassinated, they have to get that up on the front page. Otherwise, their brand is in jeopardy. This could be way worse, though. You know, if you're working for a hospital system or a nuclear power plant. You need to understand, out of all of those hundreds of microservices, what's the things that if they go bang really hurt. And you don't want the end users telling you when this happens. You want to be able to proactively sort of adjust these failure mechanisms. And you can do this through a combination of stuff. You need to monitor the flows that you understand that are critical, and you also need to ignore the things that aren't. So this is actually not a quote. This is a mantra from Sarah Wells, who's director at the FT. And there's another one that's alert, fatigue is another phrase for this, is that make sure that you have very specific alerts and make sure that you have only the things that you're going to action. Anything else is just noise, especially when you're trying to deal with a call out. You want to know exactly the thing that's causing you the most grief at that moment in time. And as I was saying, not all of these services are equal. We had one in our old system that just went around cleaning up images, old images on the system. I don't want to be called at 3 a.m. for that. But yeah, if something goes down that's taking payments, yeah. We also had this mechanism, which I love this mechanism, is that through the idempotency, we had these synthetic requests constantly bombarding our system. And this is really good for peaky kind of traffic. So you imagine the FT, people are writing a lot, 9 to 5, Monday to Friday. 2 o'clock on Sunday morning, nobody. So you end up in this kind of Schrodinger's platform state. Is it working, or have we not had a publish? You don't know what the state of your system is. So sending these requests constantly through meant that alerts would always be raised if something critical went wrong with the platform. On top of that, we added a lot of tracing. I put a link to this talk in the end. He was talking a lot about how tracing is literally the must of microservices now. And when you've got synthetic requests going through, you can trace that first ever request that caused the failure and see exactly what's going on. But be careful of trying to use this tracing and tying it to bespoke monitoring. We started out, this is a very simplified version of the content platform at the FT. So it gets some content from a CMS, some journalist writes it in. We transform it, bring it back up to a queue, and then onto a DB. We wrote something that sat over the top of this, that looked and waited for, sort of monitored those synthetic requests in particular, or well, any request coming through the system, and made sure it got to where it should at the right point and within the right time, because we had an SLA time-wise of being able to publish. What this ended up being is a little bit like designing a monolith to sort of look after your microservices, the God monitoring system, and it became very brittle and very tied to implementation, and we started to struggle with it. When you're in a sort of estimation and somebody goes, oh, that's a 3, this piece of work, and then we go, but you've got to touch the publish monitor. 13 then. I think everybody has one of these things in their system that does that. It was tightly coupled to these critical flows, so it actually meant that we had coupling completely in our system. We developed a distributed monolith by doing that. So we moved towards a slightly different mechanism, and what we were doing is we were logging monitoring events, and there's a lot of tooling out there that does this out of the box now, things like Honeycomb and such like. But what we were doing is trying to put all of our events close to the code so that we didn't have a separate application that was growing alongside or had to be maintained alongside our business critical kind of flows. We then pumped it into Kinesis and ran some really quite ugly streaming SQL. It's a work in progress streaming SQL, I think, at AWS, but it works very well if you get it right. And what that enabled us to do is to say, for these time windows, have we seen a failure? Do we need to alert? So it meant that we were flagging things close to the issues when they happened. So now we understand what our customer needs. That is quite hard, actually, but yeah, we think we do. The final thing is to break stuff. Practice everything. I'm pretty sure everybody's probably heard of chaos engineering, the principle of bringing down parts of your system and seeing how you handle it. But where in this kind of sort of evolvement, people are all over on the microservices side yet, and there's this whole migration. You know, River Island's somewhere along there. It's definitely not over there, and it's not over this side. Where at this point can you do chaos engineering? You can't do it here. You've only got one thing. If you take that down, you're screwed. But is there a point? Is there a sweet spot? When can we start releasing those chaos monkeys? Now, this can be a really good tool at any part after the one, and it doesn't need to be automated. This can be manually taking things down, and also this aids in testing the people side of things. So the support model that we were talking about defining earlier with the first line, this can be really easy to sort of take things down and see if they kind of do secret outages and see how people respond. It only works if everybody's on the same page as that. We had some very friendly developers that told first line, oh, don't worry, we're just testing this out. But yeah, no, we were constantly trying to bring things down and seeing how our system reacted. Which I skipped into this slide a little bit. But yeah, manual simulations work just as well as automated simulations. And they give you a lot of value. When we were developing this whole system, we actually we introduced a single point of failure. We had a problem with ordering of publishers. So if we scaled up our entry point into the system, we got all of our publishers out of whack, and yeah, we knew it was a problem, and we knew that we had to do some work on doing it. We knew how to fix it. However, this was one reason why we didn't go fully automated on the chaos monkeys, because if we took down the notifier, game over. But if you remember this slide from earlier on, our automatic failovers, suddenly we started using those not just for automatic system recovery. What we were doing was trying to have zero downtime deployments. So as a single point of failure, if we needed to do anything to that notifier, we'd just fail over to another region, which was good in some ways. It meant that we could handle zero downtime deployments. Bad in one other way, that we never fixed the single point of failure. But it meant that we could release with no downtime. Additionally, what happened is that everybody was practicing doing failovers. So if they were called in the middle of the night and could barely remember their name, they knew how to do this. Not only that, is that they reduced this to one tiny, tiny little command. It was very simple to fail over because we were doing it so often. And this comes back to the whole fixing things in hours builds the team's confidence in what they're going to do out of hours. You're touching various different parts of the system. You're interacting with different levels of infrastructure that you never normally do on an everyday basis. And it means that we can say what we need to do in the middle of the night. It doesn't necessarily mean we know how to fix it, but we can say what we need to do. As we're saying, that interaction made it that there was a tiny little one-liner for failovers. We made other things really easy to do in the middle of the night. This was we had a Jenkins job for republishing broken content. It meant that first line, anybody, in fact, could do it. I think some of the editorial staff even had this link. We made it really easy. And so along with manual failovers being so simple, most of the stuff we didn't need to touch. Back to the alerts, though, we had very specific content in our alerts. We didn't want people waking up in the middle of the night having to go, look in this data store, that data store, try to munge data together to work out what is the state of things. We want that one alert that comes into Slack going, there's a problem, to contain everything we needed. So this is an example of the Slack message. We've got a load of spiel, but we've also got exactly the transaction and the failed content that could be easily replayed. This is one of the most important things, I think, when designing systems and responding, is that you aren't expected to fix things in the middle of the night. You shouldn't be expected to fix things in the middle of the night. As I said, if I answer my phone and know that I'm awake, I can barely remember my name. I used to have some dreadful habits of passwords on Post-its and all sorts. We need to just be able to limp into hours when you've got enough caffeine and your work colleagues around you to actually fix the problem. So all the things that I've been telling you about the failovers that we did in particular, but all the other things, is actually just to make sure that we can still keep publishing content in one way, shape or form during the night, and then fix the following day. And you'll just have much more likelihood of actually getting to the bottom of the problem at 10 a.m. versus 3 a.m. So that's the break things and practice everything. So just to recap, mindset, we've got to own exactly how these systems react to us, how we understand what they're doing. If we don't own it, none of the rest matters. Make sure your releases don't cause issues. Make sure all of the stuff that you can do during the day doesn't result in a call. Automate as much as you can so that you don't need to be called in the first place. Nobody knows there's a problem until you get in the following day. Understand your critical flows. Concentrate only on those. Don't get sidetracked with stuff that's unimportant to the criticality of the system. Practice and break things, as I've just said. We're the people that get called at 3 a.m. We've got to demand space that we can define what that means. So it means that the product owners need to know that there's an investment that we need to make in providing this operability to our platform. We need to get buy-in that that's part of empowerment. So, thank you. I hope you enjoyed it.